Good. Hello? Hello? Yep, that's working again. Right. I can check off a whole bunch of stuff now, because we've done all of these. We've even covered a little bit about the rules of implicits.
I hope everyone asking questions has been just checking stuff off. You know,
okay.
If you need pens to check stuff off, maybe we'll find one somewhere.
So we've done the REPL, vals, defs, classes, objects, object-specific types. Oh, we haven't really done those, but I'll leave that unchecked for now. Maybe we'll have time, maybe we won't. Type conversion, factorial, rational, half, third, Scala Doc. Oh, we haven't done Scala Doc. We've done implicit conversions,
Actually,
right.
let's do Scala Doc quick, because there was an answer to one of the questions. One of the questions on why were we getting doubles from that one implicit conversion, the answer is in the int class. So if you pop open the int class.
Okay, this is Scala Doc if you haven't seen it. I love it. People vary. A lot of people don't like it. I can't see why. I think this is really neat. But you can search for things, first of all. That's a nice feature right there. Just jump straight to int. Another thing is, we've already talked about companion objects and classes and companion objects. When you see a little peel over bit here, you can click on that. This is the class, the C, but you can also click on it and get to the companion object and see what's on there. But I'm guessing what you need is on the...
Yep. So this guy, if we look at the int method, you can see that actually everything is overloaded. And you can see that int actually has a def that takes double. And since it has a def that takes double, Scala prefers the fact that there is actually a method there, and it's going to use our implicit that converted rational to double before it even looks for something that takes an int to a rational, because it's going to prefer the method on the class first. That's the first thing it looks at. This is one of the first precedence rule for implicit conversions.
And one more thing to mention on Scala Doc is sometimes there's a method out there, but you can't remember which class it's defined on. What you can do, let's say reverse, for example, is you can actually click on the letters at the top here, and it brings up all the tokens it knows about in the system. So we can look down here for reverse. REV is down the bottom somewhere. Reverse. And then it tells you all the classes that it's defined on, which can be very useful. So now you can go in and see that stream, for example, has a reverse method defined on it, and lots of good stuff. I love Scala Doc. Oh, and I said one more thing. I lied, because there's even one more thing, which is that when you're in the Scala Doc, you can always click through to the actual source code, which is very nice. So it brings up the GitHub source code for Scala. So if you really want to see exactly how it works, that's pretty useful at times. Right. Okay.
Why doesn't it just go straight to the source code, right?
You just skip the Scala Doc altogether.
Isn't that who prefers source code to documentation? Just curious. All right.
You just haven't...
My brethren.
That means people haven't written the documentation properly to me.
Oh,
that's all that means. I mean, sure, that's true for most libraries. That's because nobody's written any damn documentation. Right. Okay, so Scala Doc, good. Right.
Why would we ever, write the documentation if we've got types?
Well, and you see, so the question is, why would you ever write documentation if you've got types? That is the argument for Scala Z right there. You've summed it up very nicely.
I think one thing I will say is that types let you write less documentation.
Yes.
So the type is already there. You don't have to actually say this returns a foo. What you do have to do is you do need to document semantics, because the name that you might have chosen for something could be some hazy idea out in Platonic space that doesn't really have a real world example. And so the language that you're trying to describe it with is you can't actually pick a good type name. So you need to actually expand that with documentation. A good example, take a look at the, I tried to write the documentation for continuations in Scala.
Oh, what's the,
just look for the continuations, the package.
Oh.
Lowercase, yeah. Click on that or control context. Actually, control context is a good one.
Why are we showing them this? This is scary.
Yeah, this is scary, but writing this docs, most of it is describing the concepts behind it, right? Not necessarily once you understand the concepts, the types actually are simple, but the concepts are the killer. So describing that, the semantics, that sort of thing, that's what takes doc. You click on control context just to see how much docs there are. You know, there's more. There's some emphasis. Another thing you'll see in Scala, which I think Java 8 will force you to see in Java 8 or in Java docs, is more examples at the top of classes. Because functional interfaces, you cannot document without showing examples, because pieces are here and there. The old Java Doc format just doesn't really fit well in that mentality. So I think you're going to see that show up in Java Doc more and more. If you don't see an example at the top of Scala Doc, yeah, please contribute one and yell at the person who wrote the initial one. Hey, examples. Anyway.
So prior to the break, we taught everybody exactly the wrong thing to do, and then everybody left and probably didn't come back again. So I realized that we've probably just seeded the world with a whole bunch of Scala developers that now only know the wrong way to do things.
Or people who are going to complain about Scala for...
Yes. If anybody wanted to go and write a blog post on why Scala sucks, we just handed them the keys to that one.
We have more information if you need to write that.
Yeah.
Just ask.
But anyway, now we're going to look at some of the ways that you can do it right. So this is the first one. Let's get rid of this for a minute, because that's a concept that we'll come back to. How can we use an implicit conversion safely? Well, here's the key to an implicit conversion. I think this is one of the... It's not an inviolable rule, because there are times that you need to do clever things. And, you know, that's the thing with Scala. Never say never. It doesn't say, oh, you'll never need to do that, so we'll take that away from you. Java does do that. Java says, oh, you'll never need to do that, we won't give you that one. But the safe way to use implicit conversions is to make sure that the type you're converting to is a type that you own. Okay, it's one of your types. Bad implicit conversions do things like convert ints or strings to ints. Okay, that's a bad implicit conversion. One of the reasons it's bad is you don't own int. You've just taught it to do something to two types that you really haven't got any big stake in. They're just there for you. So if you have, instead, if you adopt this rule that, well, I can do an implicit conversion as long as it's to a type that I own, then most of the time that's okay. And here's an example of that. So I mentioned earlier on, one of the things that we use implicits a lot for is to apparently extend the functionality of other things. An example of that is, I'm sure everybody's seen hello. Hello is a Scala string, first of all. Sorry, a Java string. That's a Java string. I can say hello.to uppercase. I'm doing it now. Case. Okay. And you'd expect that to work. That's a method on a Java string. What about if I type hello.reverse? Anybody seen the reverse method on Java string before? No, but it works. Okay, it's very convenient to be able to just reverse a string like that. But that's not a method that exists on string. What is it defined on? Is it wrapped string or rich string? Or is it some other?
I think it's probably rich string or
rich string.
String to traversable.
There's in the Scala standard libraries, there's various decorator classes that are out there like this. I can't remember whether it's called wrapped string or rich string, but they tend to be either called wrapped or rich a lot of the time.
You can show the Scala Doc.
Yeah.
Let me ask you about it. How can you know what's the source of this reverse method?
How can you know what the source of that method is?
I don't mean source code. I mean the origin of where this method.
Okay, that's a good question. So how do you know where an implicit's coming from is basically the problem. There's a couple of answers. Both of them are somewhat of a cop-out. The main one is use a good IDE, which will tell you exactly where it comes from, okay? And that's quite nice. IntelliJ, if you use an implicit, IntelliJ puts a little underscore underneath it, it underlines it for you. And if you command hover over it, it tells you the method, signature, where it comes from, all of that good stuff. So that's a nice way to do it. The other way is to do what we're about to do and go and look it up in Scala Doc. So let's go.
There's a third way, and that's to turn on compiler debugging.
Yes. Oh, yeah.
It'll just dump out. So the compiler, you can actually dump out the full tree of everything that your code turned into in all its gory ugliness. And then you can almost copy and paste that into Java C. I'm joking.
If there's time.
Yeah, that one's...
We'd rather get the the important things down.
The command is actually show, so you can look that up later.
Is it string?
But you can say show the tree of your code at a particular phase. If you're debugging implicits, it can be handy. There's also a specific implicit debugger for compiler authors that you can make use of.
Is it string builder? That doesn't sound right.
No, go to string itself. If you look at string, it should tell you implicit things that are available. There's a yeah. So I think it actually.
String, but that's a Java class though. I think it might be string. Oh, string ops. It is string ops. Down here somewhere. There's a lot, as you can see. This is quite commonly used. Yeah, there it is. Okay, so it's string ops that it's providing, and then there's a wrapped string too. So
yeah, that one. That's
anyway. We should not spend too much time on it. I'm happy, more than happy to discuss this at the end, but we want to get to the good stuff. There's really good stuff coming. So here's a safe way. Here's a safe thing that you can do. This was added in 2.10 or 2.9? 2.10, I think.
2.10.
Implicit class.
Yeah.
So instead of what we did before with rational was we created a class called rational, and then we created an implicit conversion from int to rational. And that's okay because int is somebody else's class, but rational is ours. So we've taught it how to promote some other type in the system to our type. In a lot of cases, that's one of the most common cases that you want to do. What you can do instead is combine those two operations now in Scala. And that's known as an implicit class. So when you define the class, you actually stick an implicit keyword in front of it. And then that's like saying, I'm defining string Swizzler, and then whatever this thing is in here, this parameter, we're going to automatically provide an implicit conversion, an implicit definition, or an implicit method to convert from that thing to one of these. And you see, what that's done, first of all, is saved us a whole bunch of typing. Yay. That's good. On top of that, it's made sure that we're defining a type. It's our type. And whatever the other thing is that's coming into it, that doesn't really matter. You know, it's some other type in the system. But the key is the destination is a type that we own. So it's kind of making you do it right. It's giving you the easy way to do it right. So what string Swizzler does, because all the good stuff is taken. They've already got a reverse and stuff like that. So I just decided to take the first character in the string and move it to the end of the string. Because, you'd want to do that all the time, right?
Yeah.
That's very common. One thing you need to know about an implicit class definition, and this is one of the rules of the JVM, is it has to go inside something else. And the reason for that is, behind the scenes, the Scala compiler actually makes this class, and it writes for you a little conversion method after it. So it will be something like string to string.
It'll actually be called string Swizzler.
Well,
Yeah,
okay.
capital.
So it's actually called string Swizzler.
Yeah.
Okay. That's good to know. I didn't know that. And that will take an S of string. It will return a string Swizzler. Mm-hmm. This will be marked as implicit.
Yeah, and the implicit gets dropped.
And the implicit gets dropped off the other thing here. So that's kind of what it's doing for you. Now, the reason it has to go inside that object is because you can't just have a method floating out there in space in the JVM. Okay? Methods and fields, they have to go into an object. That's just one of the restrictions. That's why, in this case, we've got a singleton object called demo around this, and you quite often see this. People put objects. There are things called package objects, which is a little beyond the scope of where we're going today. But I should mention that we do Scala training. It's a great time for a plug. So if you want to learn all about things like package objects, come and take our Scala training.
One thing I want to mention. So the implicit class thing is actually a proposal I put together for 2.10.
Nice.
And
I did not know that.
It's purely syntactic sugar, like as you just saw. So it creates a method. There's actually a lot of Scala features where we've recognized there are, things in the language that are a bit verbose, and then we just make a rewrite. And it works similarly to how it did before. And so semantically, things are kind of the same. Like case class, it literally is creating methods for you. You can do all of the case class work by hand if you wanted to. Same with implicit class. You can do all of that work by hand if you need control of it. But if you're following the standard conventions,
Yeah.
you just write implicit class and it's there.
It's a win in a couple of ways. It's less typing, but like I said, it also encourages you to do it the right way. Okay, it makes it super easy to do it the right way. That's a good thing. Don't stop people doing what they want, but make it easier for them to do it the right way than the wrong way. That's a good philosophy. So now I've just loaded that in. One of the things you'll notice is when I loaded that class in, I didn't get a feature warning because, hey, this is fine. This is considered good. Now, if I try and take my string and say hello dot swizzle, it doesn't work, okay? Oh, why didn't that work?
Not enough swizz.
Not enough swizz, yeah. Perhaps not enough coffee. Now, the reason is that one of the implicits are not as dangerous as a lot of people have been afraid they are, I guess, or blogged that they are. Blogging is a wonderful way to learn all the things that aren't true about something. But anyway.
Unless it's my blog.
An implicit will, there's quite a few rules. We'll get to them at the end. But one of the main rules of an implicit is you have to invite it in. It's like a vampire. Okay, it has no power unless you actually invite it in. So
there's a threshold, guys.
Was that actually really? I've used that before, but no one's ever laughed at my vampire thing before.
Well, I think Dresden Files is more popular now. I don't know.
Okay. Oh, okay. Right. Fair enough. But anyway, yes. Holy water and garlic and all that stuff. But yeah, the point is that we actually have to take action to bring this in, and in this case, this means importing that implicit in from the object. So now if I say import demo, now I can say hello.swizzle, and it works. So that's the good way. Everybody who came back from the break, thank you for letting us show you how to do it right and not running off and saying, Scala's the devil in multiple blog posts.
They're probably still saying Scala's the devil, but hopefully for the correct reasons.
All right.
No.
This is idiomatic now. This is the way to write extension methods, and it's safe. There is one problem with this particular approach, which is that as nice as this is, it still is actually creating a new instance when you do it. So what this is doing behind the scenes is saying string, actually I can't even do that because it's not a case class, new string swizzler of hello. And then I'm going to have to put this whole thing in parens, I think. It's going to get grumpy with me if I don't. So let's add a parens around that. So, and then dot swizzle. Okay, that's what the implicit is actually doing. It's writing that extra bit for me. And so what you can see here is it's creating a new instance, right? It has to. And that, probably isn't the biggest concern in the world. All that stuff about eager optimization being the root of all evil and all that sort of thing. But it would stop people using it in tight loop situations and things like that. Yes?
Why have you put that constructor in parentheses?
Just because I think the parser gets a bit confused if I don't. I seem to remember it. It doesn't know what the dot swizzle is referring to if I do it. Oh, it does. Okay, that's just a habit then.
What happens if you take the new away? You should do it.
If you take the new away,
yeah,
it's not a case class, so...
But why does it work?
Because there's an implicit.
Because it's a def. It makes the def with the same name as the
that's
class.
right. The def is called string swizzler.
Right. Remember how it desugars? Yeah.
Oh, that is nice, actually.
Anyway.
Did you think of that? You're quite bright,
actually,
really, aren't
no.
you?
Martin fixed my proposal.
Oh, okay.
When I said I made the initial proposal, but Martin fixed it.
All hail Martin is all I can say. He is quite the clever chap. Right, anyway, so... That's what it's doing, and it's creating a new instance. Now, some people... Oh, yeah.
Once again, explain why does this work? Is it because this implicit class is transformed by the compiler into a method?
In this case, there's no... So in this specific case, there's no implicit bit at all. Okay, we've done everything explicitly.
Yeah, and this works because, like we said before, the implicit class is transformed into a class and an implicit method with the same name as the class in that scope.
Yeah, but in this case, where we just say hello.swizzle, that looks for a swizzle method. It doesn't compile, doesn't type check. So the Scala compiler says, are there any implicits that would make this work? Yes, there is. There's this one that will basically do this. And so it does it. Does it for you. Okay, so the problem that we're coming back to is we've still got this extra instance creation. So this is a really nice thing that was added also in 2.10. That just, if you, this is kind of the best practices as they exist right now. If you make this, so actually what I didn't have to do at this point is that could have just been a private S of string, okay? In order for this to work, you do have to make it a parametric parameter, or public parameter.
It has to be public, and there can only be one.
Yeah.
Like Highlander.
Right, there can only be one. But what you can then do is you can say extends AnyVal. And it's a bit of a weird, it's difficult to describe exactly why extends AnyVal was used. Maybe you can.
Have we described the difference between AnyVal and AnyRef yet?
Only glancingly.
Yeah, so here's something in Scala. In Scala, everything is an object.
Yes.
Everything. Remember, int has methods, plus, minus, that sort of thing. However, at runtime, is int an object in Scala? Anyone know? At runtime, is int an object? Is it the object form of int, or is it a primitive at runtime in Scala? It might be a primitive, it might be an object. You don't know. Exactly. Yes. That's the right answer, yeah. So the fact is that int can be a primitive and it can be an object, and the compiler tries to preserve it as a primitive as often as possible, which means you cannot assign null to it, or the compiler wouldn't be able to optimize that, right? It wouldn't know if it can. It's not safe to take null to an integer. Okay, what do you take it to? So what they have in the type system then is you have any, which represents any type in the whole hierarchy, whether it be something that could be primitive or something that is always a reference. And then we split. AnyVal are things that could be primitive or not, and AnyRef are things that could be references or not. What we're doing here is we're actually creating a custom class on the AnyVal side, which means things that could be boxed or unboxed.
Yes.
As opposed to the AnyRef side, where everything is always a reference and there's unique identity. On the AnyVal side, you do not have unique identity, and you may or may not actually be an object at runtime. You could just be the...
That is actually a great way of... And the reason... another aspect of that is, we haven't mentioned this, but when you say a class just like this, okay, just like in Java, what that's really saying is extends AnyRef.
Yeah, the compiler actually adds that for you if you don't write it.
That's equivalent. It just leaves that out because Scala has another rule, which is don't make people type stupid stuff over and over again. If only we had that rule in Java.
Well, except for, colons and parentheses. We love those. Those are still cool.
Yeah.
You can make little faces with them and stuff. I mean, they're still pretty cool.
So anyway, the upshot of all this, the reason we're laboring this point is when you extend AnyVal, what goes on is really rather clever. In the Scala compiler, what this means is that you can still add extension methods, but there is no extra object creation. This is all turned into statics behind the scenes, so it's super efficient. Okay, so if you can do this, you get all of the good stuff of implicit classes and extension methods for free. Okay, your code looks nice, you get the convenience, and you don't pay any runtime penalty. Yay.
Yeah, and again, this is, it will try to prevent it from boxing when it can. So in the case of the actual implicit, it will prevent the boxing because all the types are known. If you were to throw these things into an array of object, then it would be boxed, right? Because we don't know what you're throwing in there, or sorry, an array of any.
I did actually have a demonstration using Java P, but I'm going to hold that one because it'll take time, and I'd rather get onto the other concepts. If there's time at the end, we'll actually show you the difference in the code that it produces when you do this. But just believe us for now. Super efficient if you can use extends AnyVal. Right. What's next on my checkbox of things? Implicit parameters. Okay. Why did I put that there? That was just the wrong place for that. Okay, so implicit classes are the new black, extension methods, Scala typing. Oh, we've done all these. Collections. Oh, very quickly, I did use a couple of things that I didn't really show there. Take and drop, which are implicitly available on strings. Okay, so that's one of those things in the string ops. Drop is very nice. Both of these are wonderful because they work in all sorts of ways. If I say hello.drop 2, it just gives me the remainder of the string without the first 2 elements. And if I say hello.take 2, it gives me the first 2 items. That's easy enough, but what's really nice about these is you can also call them safely on empty stuff, and it just says, you know what, you gave me an empty string. I'm not going to bust you, I'm not going to give you an array out of bounds error or something like that. Yes?
Try executing take with -1, and guess what happens?
Oh, I've never tried it.
Now guess, okay.
I think that was fixed, but there used to be a bug there. Yeah.
What did it do, out of interest?
I think it.
Oh, I see, just doesn't, okay. Anyway, so yeah, what's nice about that is it's a fairly robust function, and in this case it means that I don't have to think about the fact that the string may be empty when I do this operation on it. I can just
Oh,
do
there's
it.
2 questions up here. Yeah.
Yeah.
What's up? If you use synchronized on an AnyVal, I don't know if you can. Let's try that out quick.
What am I going to say? Just synchronize the
just-
whole
just-
thing on
no,
S?
No,
or?
just create in the REPL. Just create an AnyVal and
Oh.
try to do synchronized.
Oh, I see what you're
Just
saying.
try to call synchronized with empty.
Okay,
bracket.
so we can create an instance of, well, we can't create an instance
just
of
do
string
like
system.
5.
Oh.
Or like yeah.
I see what you're saying. Val AV of type AnyVal equals 1. Okay, and then synchronized thread?
AV.synchronized.
AV.synchronized.
Yeah.
Oh my goodness.
I'm pretty sure you're not allowed to do this. Yeah.
Okay.
It's actually not defined on AnyVal. So you're not allowed to do it. You might be able to do it on certain types like int or string, where there's actually a intern pool that you're pulling from. So if you unbox back into an integer, for most integers, you actually get the same thing. That's actually really stupid to do anyway. I would not recommend that. I've seen code like that. It was riddled with bugs. So I don't recommend syncing on ints. If you need an object that has identity to sync on, just create a new anonymous AnyRef. You can create object lock extends AnyRef. Great, bam, you have a lock. You can use it as a lock. The fact that Java conflates every object with locks is kind of bad, my opinion.
Alternatively, look at some of the other options that you have available as well. So,
Yeah.
yes, I see another hand up there. Are there reasons that you can't extend AnyVal? Not a tremendous number, I don't think.
there's not.
You can usually use it.
AnyVal has a lot of limitations in certain things that you have to do. So you can
You have
only
to make it a val.
You can only have one argument to your constructor. It has to be a val, and that's the thing you're going to box in and out from, right? The other thing is you can't have any sort of state in your class. So you can't define vars or vals in your class. You can only define methods against it. Because again, if you're boxing or unboxing,
there's nowhere to put that.
There's no state besides the thing that you're taking in. So
but the
everything has to be a method.
compiler will enforce that. Honestly, most of the time, if you're doing an extension method, it just works. So, and the compiler will tell you if it won't. So.
Yeah, we spent a long time making sure that AnyVal error messages were enough that you know how to fix things. There's still a few corner cases if you're doing weird types, throwing them into the AnyVal. Like if I have some crazy abstract type that I try to make an AnyVal of, where the compiler can't really figure things out well, then some wonky behavior happens. But that's the limit of where the bugs are now. So
that takes us all the way down to why not extension classes? Why did they do it like this and not have some kind of keyword that was extension or something like that? I think that's just in general, Scala tries not to consume too many keywords. That's the reason why I think I'd make a pretty strong case in a philosophical debate. Never, I wouldn't take this corner seriously most of the time. But case classes, there's a fair case to be made for calling those value classes, because a lot of the time that's what people are really using them for. But the thing is, case is already a keyword in there. And if you took value as well, that's another keyword lost. And a fairly valuable, no pun intended, or maybe pun intended, keyword to take away.
Always pun intended.
So extend AnyVal, it's a bit weird, but it sort of fits in with not burning up a whole bunch of other stuff to call it. And safer because you own the target types. Right. I was going to, we were going to have loads of time for this. I was going to talk more about the collections. That is easily a day in itself, just going through the collection classes and the collections API in Scala. It's wonderful. Okay, things like take and drop and take while and just incredible richness of stuff that's available on both, on all the collections and on strings through string ops. If you want to get good at Scala, you can't spend, when you're learning it, you can't spend time better, I don't think, than learning the collections API. It's really very powerful, very good. So that's my PSA, my public service announcement. Right. Implicit parameters.
Yeah.
Now it gets exciting, because there's this other thing, this other side of implicits that we really haven't talked about a lot at all yet. First of all, has anybody heard of currying here? Yep, got a few. You guys must be functional programmers, or
not related to food.
Yeah, well,
which is my favorite type of curry.
Yeah. Okay. So here's a definition of something like an add method, add 3, and we can say A of int, B of int, and C of int. And then we return an int, and that's A plus B plus C. Oh, not class, just C. Right, add 3, 2, 3, 4. Hooray, just wrote something. Now, this is the Java way of doing things, and the C way, and many, many other languages do things this way. There's another language that I'm sure you've probably heard of called Haskell, and many actually then, I don't think they were the first to do currying, were they? No, by a long way. No. But in Haskell, things are a bit different. There is literally only one parameter. Okay, there's one parameter and one return argument for everything you do. And it's a bit of a mind twist, but the way things work in Haskell is that your return, well, either your, we've seen this a lot already when we did things like map x's, okay, val x's equals list 1, 2, 3, and we say x's.map, and I'm going to use the underscore notation because it's not scary, despite what people say. That just means add 2 to everything in that thing. This is known as a higher order function because it's a function that takes another function. Functions can also return functions. If you have a language which only takes one thing and returns one thing, and you want to have multiple parameters to it, what you can do is have them take a parameter and return another function, okay, that needs another parameter. And then you have another function that needs another parameter. And when you finally get all of the parameters, you can then execute the function and you get back the answer. And that's known as currying. There's a couple of ways you can do this in Scala, but the main one, the reason we're kind of diving in, there's a lot more to talk about currying. But the main one is that you can say add 3 curry. Let's call it that. And instead of saying A of int, comma B of int, we can close down the first parameter list and have a second parameter list, and then a third parameter list equals A plus B plus C. Okay? And now we've got the same thing as we had before, except we've got 3 different parameter lists. When we want to use this, we can't say 1, 2, 3. That's wrong. It's too many arguments for the first parameter. What you can say is 1, 2, 3. And that works. Okay, that's one form of currying. There is actually a much purer form with function literals that we could demonstrate. I had actually produced it, but I think it'll take too long. If you want to see it quick, it looks a bit like this.
Does this add anything other than the compiler can infer type for another parameter list?
There are several things that implicits give you that are useful. Curries that give you that are useful. One of them is, yes, you can actually use things about the type. What is it? I'm trying to remember exactly what it is.
The compiler does type inference by parameter list from left to right order.
Yes.
So if you infer something from the first parameter list, you can use it in the second without having to re-specify. That's important, like the map method. You don't have to specify the type the function takes in. You can just write _+2 because you know the list has an int in it. Well, you can also do that with currying, where you can use the type you've discovered in the first, parameter list when you look in the second one. So that's one of the most useful things for currying. Yeah.
I'm mostly familiar with currying from Ruby, where you can actually have a method and you say method that takes 3 parameters in the normal way. You say .curry and you already fill in 2 of those and you get a resulting method that just needs 1 more parameter to work. Is that possible in Scala as well?
Yeah.
Another way?
So the question is, in Groovy, there's a .curry method that can take a method and turn it into curried. Yeah, in Scala, there's a .curry and a .uncurry on function. So do you know how to lift have we talked about lifting methods into functions? We should do that real quick.
Okay.
Can I?
Yeah.
Okay. So if I have a method.
What's your?
All right. So
We'll
foo.
switch
No.
your machine in
Let's
after
make
this.
add. I'm gonna use this method. We're gonna add an x and a y, and we get back x plus y. All right. So if I wanna create a function out of this, I can say add _, and that lifts the whole thing as a function. Okay. On function, I can call .curry. Or I thought I could call .curry. Is it .curried?
Yes.
There we go. Sorry. Now it's a curried function. You can deal with it as it takes an int, returns a function from int to int. So now I can say f.curried, pass it a 1, I get back a new function, result 66. Ooh. Pass it a 2, and we get 3 as a result. See, so you can curry.
That's true currying right there.
Yeah.
Okay, while Josh was talking, I set up, and we're going to start getting, you guys are big enough now that we can start sort of laying on good practices with you, okay? Scala's a typed language. It's a really, really, really typed language. It loves types. And one of the things when you're working with implicits that you really want to do is just create types at the drop of a hat, okay? This is your documentation in the system. Don't be afraid to create a new type for something. It's good. It's a good thing to do. So what I could have done, I want to write a method which is called greetMe. And I could have said n of type string and g, the greeting of type string here. And I could write it like that. I could also curry it, okay, like this. So I could have the name and the string. But what I chose to do instead was actually create a greeting and a person. So what we're going to say instead is I created my case classes. I'll show you those in a sec. But you see, what I've done is just made the person and the string, and the greeting, new types rather than just using strings for them. And this gives me all sorts of advantages now, right? Because one of the things is, what if I get them in the wrong order?
Scroll off.
Oh, sorry, not far enough. There's my case classes, greeting and person. It's not much overhead to do that. They've both got strings inside of them. But one of the real advantages to doing this now is I can't accidentally get them in the wrong order, because the compiler's going to make sure that the thing that I give is a person and then a greeting, and not accidentally mix them up and get a greeting and then a person. So you've already made life better for yourself by doing that. So now I can say greetMe as person and greeting, and I'll say equals, and we'll make it the return type a string, and we're going to say s p.name, $p.name, stop helping me, and g, what did I call it? .g. Like I said, names are us. Come and see us. We have
need a dollar
26
there
of them.
too.
Oh yeah, dollar.
Yeah, that's the money GG.
That's it. Money GG. Yep. Okay. So there's my method. I can now say greet me, Dick, with you look fabulous. Thank you. All right. Oh, wrong way because I made it carried. Did anybody catch that? I heard somebody say something. Gold star to that man.
Luke.
The force is strong. I can't do that because they're types. So I need to say, well, this is a person.
That's the greeting, right?
That's the, oh, no, the person was first, I think, wasn't it?
Yeah.
Person
yeah.
first,
But
and
the
then,
compiler would tell you that I was
that's
trolling you.
right. Oh,
It
yeah.
would, yeah.
And greeting. Okay. Good. We're getting there. Dick, you look fabulous. Well, thank you. I feel so much better now. Self-affirmation is surprisingly underrated while programming, you know. Now, what can I do with...
So Dick is of type U as well. That's great.
Oh, yeah, the colon. Yeah, maybe that maybe that was the wrong thing to... Anyway, so that's greet me. Now, one of the things I can say is, well, I think a lot of people look fabulous. I'm an optimistic kind of guy. And it might be that I want to have a standard greeting of you look fabulous. So let's do that. If I change my definition back up here, and instead of just G of greeting, if I put an implicit in front of that, what that means to Scala is, if this isn't filled in, okay, go and look for one of these and see if you can fill it in for me.
And to clarify, that's the entire parameter list.
Yes. Yeah, the rules of this one are the implicit, if you use implicit parameters, the entire parameter list is implicit. It has to be the last one, and only one of them can be implicit. Okay? Those are the rules that that's the hand you're dealt. But it's good enough for most of what you want to do. So here we say implicit G of greeting, and if I now say greet me, person Dick, what happens? I did define greeting, but there's an important step that I missed, right? I did not define it as an implicit val yet. So if I do this, it says, well, I couldn't find a parameter, an implicit parameter for that. So tough. You can't do that. That's a compile error. If I now say implicit val standard greeting equals greeting you look fabulous, then I can say greet me, person Dick, you look fabulous. Josh, do you look fabulous?
No. Your beard is scruffy.
No, you do.
I think...
Okay,
right.
so if you want to insist
I
then,
wanted to tell me my beard's scruffy.
then in that case we can still explicitly define the parameter. Greeting your beard could maybe use a slight trim. I'm English. I have to be polite.
Okay.
It's in the genes. So there we go. Okay? So another rule that we've just learned about implicits is implicits can always be explicitly provided. Okay? Now, one of the things about that implicit parameter list, that, as we mentioned, the implicit applies to all of the parameters in that list. You can't mix and match. Okay? Either the whole thing's filled in implicitly or the whole thing's filled in explicitly. There's no in between on those. The compiler will do all the work on none of it. But it is very useful. Now, where this is used a lot, as I mentioned in a lot of the akka things, is when you do something like, I think there's a reply method, for example, and you can give it some,
A
message here. There's also an implicit timeout, some kind of duration, like 5 seconds. Okay? You don't have to supply that. You can just make an implicit parameter available, and that's it. That's within a scope. That's another thing we haven't talked about, but implicits are actually super powerful because they can be scoped. And if you import, because so many things to talk about, imports in Scala can be scoped. You can actually put an import inside curly braces, and then that thing is only active within those curly braces. Yes, I see a question. Could you use it as a form of dependency injection? Funny enough, yes, you can.
Yes.
In fact, I wrote something to do that.
Is there a library that does that?
There is a
Dick?
library that does that. It's
What-
called Subcut.
Is it under the Dickwall GitHub?
It
account?
is under the
Okay.
Dickwall GitHub account.
All right.
It's in version 2.0. I'm working on version 3. I just never seem to quite get around to completing it. But yes, that uses the idea that if you follow the simplest a chain of the simplest things that can possibly work, you end up with configuration that you inject using implicits, and they just bump all the way down through your system, you can change them at any point because of the rules of implicits. If you say, well, I've got this far, but now I'm in a test, say, and I want to change this one thing, then you can open up a new scope, you can define a new implicit, or just explicitly provide different configuration, and from then on down in the tree, it uses your new configuration.
Yeah, so one
All of those
really
kind of
interesting
things.
thing that happens here, in practice, akka and play use implicits to pass the future context scope, you know, and like web context and stuff through your application, which is one way that they don't have to pin to a particular thread. Why do servlets and lots of servlet frameworks pin you to a particular thread for the entire request? Anyone know? Like Spring, what? Thread locals, right, because thread locals are the implicit of Java. When I need to pass context down through things and I don't want to have people write it over and over again, what do? I shove it in a thread local and I leak memory. Yay. Okay, I only say the leak memory part because almost all the thread local stuff I've had to deal with from a tools
Leaks
aspect
memory.
has leaked memory
Yeah.
and or classes, and we usually ask people not to do that. But anyway, so before you would do that with thread locals, which you could still do that in Scala if you want, but now you have this other mechanism to pass things through. Database transactions in a lot of database frameworks in Scala tend to be passed through implicits. What thread you're running on, you know, web context, that kind of stuff comes in via implicits. In play, you just annotate the parameter you're taking in for a request as an implicit. Bam, it gets passed through to the various threads you're operating on. So your scope is now tied to your lexical scope instead of threading scope. So instead of runtime scope, it's lexical. And if those two words are bad words, I'll come up with new ones in a little bit once I think. Anyway, yes?
One question about this curry definition. I was expecting that I can partially apply a curry function.
You can.
You can partially apply a carried function, but one of the things you can't just say, because it would be, I think it would lead to more, I think the decision was made because it would lead to more confusion if you were able to say greet me, let's say I've got a thing called, a variable called dick in there. You would think that you could actually say this is a partially applied function, right? And that you can fill in the other thing later. But it actually leads to quite a lot of confusion if that compiles at all, because what you really want it to say is, well, I want it to use the implicit here. And if there's not an implicit, make it a compile error. And what you can do, if you want to make it a partially applied function, you can just do that.
Throw the underscore.
Okay? The underscore means, I know I'm missing something. Deal. Okay?
There's one other exception to that rule, and that is if you have a method in that case that takes, if you have a method that takes a greeting, or that takes a function from greeting to string, you can actually pass greet me person dick, and it won't apply the implicit. It will lift that as a partially applied function because your expected type is the function returned from the first part of the curry. So it doesn't try to complete the implicit because you've matched the type already, if that makes sense.
Yeah.
And that's actually how you do a lot of like when I was talking about single method, or this comes back to the operator chaining and how I have lots of operator chaining. I make these helper methods. I oftentimes make a curried method where I pass something to the curried method and then it returns the method that gets sent to like map or filter or whatever. Because that's another technique of currying that's really useful, if that helps. If the compiler knows if the compiler knows the type of a function, you don't have to throw the underscore. But if you manually want to curry, then you need the underscore.
Also, if I don't have an implicit parameter list, then I also don't need to have
Yeah, so the question is, if you don't have the implicit parameter, then you don't need the underscore. That's also true, I believe.
Yes.
Yeah.
Okay, now
We got one more.
one more question? Yeah.
So the partially applied functions, how does that actually work? Does it hold off?
How it works, a partially applied function from a method like that, what it actually does is it does the lifting, the function lifting that Josh showed you earlier. So it turns that thing into a function literal that has the parameters filled in that you've got, but it's waiting for the other parameter to be filled in. And then what we haven't really shown you, because they're just, I'd love to get into all these topics, but there just isn't time for them all. Come to our training. But any function or any function literal in Scala has a .apply method on it. Okay, that's how it works. It's just a class with a .apply method on it. And so when you actually invoke it with the final parameters, the .apply method gets called on it automatically. And that's how that whole thing gets
That'll chain
gets
back to
run.
the original method.
Yeah.
So it holds off on evaluating the actual method until it has all the parameters.
Yeah, it'll
Right.
construct an object which has the parameters you've passed it so far, and on its apply method, it will eventually chain back.
Yeah. When you've seen me do this, like when you say list 1, 2, 3, this is just a rule of Scala, is when you have some item and you immediately follow it with parens and things inside of the parens, or possibly not things inside of the parens, could be empty, that actually calls list.apply, which is the method on there, with those values in it. Does exactly the same thing. So it's syntax sugar, but it makes it very convenient for things like factory methods and stuff like that. And it's just a general rule. It also works for functions, because if you did f123, where f is a function, it calls f.apply 123, and it works. And you can, once you know that rule, you can override apply in your own methods tastefully and do all sorts of things with that as well. You can use it for that rule for whatever you want to, really. So I see another question back there. Yeah, so the question is, can you only have one implicit parameter? No, you can't. You can only have one implicit parameter list. That list can have multiple implicit parameters in it. Let me show you a quick example. So instead of just the greeting, we'll have a greeting and
Greeter.
implicit. I was going to do an insult. Comma.
Implicit is missing an I in the after the C.
Oh, thank you. Implicit, greeting, and insult. Oh, I haven't defined insult. So case class, insult, I of type string. Right. There's my insult. Oh, I need to probably and string I.
I.I.
I. Love the. We're so good.
I like GG better.
GG and I. And then I can say, right now I can say, actually I should make the implicit val insult. Another thing I wanted to mention here is name doesn't matter at all types, okay? What's important is this is of type insult. I could call it Fred here. It really doesn't matter what you call this thing, but the type does. And you look like, you look like a horse. Oh, but you smell awful. Awful. All right. No, I don't want to save it. Just want to. And now I can say greet. Greet me. God. More haste, less speed. Dick. New person, Dick. Person, Dick. And, I put an and in there too, but never mind. It mostly works. You look fabulous, but you smell awful. Right, so that's brought me back down to
That's
earth.
conjunction junction, right?
With a bump, yes. So that's how you do it. There's one implicit keyword at the front. Either the whole parameter list is implicit or none of it is, but it can have multiple parameters. Yes, I see another hand. Can you combine default parameter with default value? Yes, you can.
Yes.
And I believe if the implicit's there, it will use the
If the
implicit.
implicit is there, it will use the implicit over the default parameter has the lowest precedence of
Yes.
all. So it will use the default if there is no implicit available.
That's right.
The other thing is there are tricks you can do to override implicits within scopes and things. You should totally get Scala In Depth, the book, and read it. It's
Good plug.
I believe it's
It is
yeah.
actually a really good book.
chapter 5, 6, and 7. Yeah.
It is a really good book. One more thing I wanted to mention very quick, because then we've got to get onto the...
The book
The book, actually, the book was mostly written for Scala 2.8, but yes, it covers 2.9. It's missing some of these new 2.10 features. That's true. When I finish the next book, then we might go back and update it for 2.11. Yeah.
So I'm moving on because I want to get to the exciting payoff. I'm not sure we're going to make it all the way to implicit evidence today.
20
but
minutes.
We should at least get implicit or type classes in there. One more thing I wanted to mention is the implicit not found annotation, which is lovely. If you can use this to actually provide extra error messages during the compile phase. So, this is an easy thing to add value. You just say implicit not found, at implicit not found. If it can't find one of these when an implicit is asked for, it says, please define an implicit time unit to be the default, or something like that. And you can pump up your error messages in the compiler with that. Right, Josh, I think that does it for that. So now we're on to type classes. Do you want to drive? Are you comfortable with driving mine?
Yeah.
With all of the
Comfortable
horrible...
in that I think I'll do some awesome here. All right. So type classes are a way...
Here. Move that up there. I think that will make it less prone to jumping around when you
Cool.
accidentally click on it.
Type classes are a way of defining classes or defining behavior like external to a class. It's kind of a concept, I believe we pulled it in from Haskell. We found out that we could use implicits to do so, and it's really, really powerful. So what I have here is this fake class. We're using Scala's JSON library, which I would say is the weakest of the 30 JSON libraries in the JVM ecosystem. I
just want to take the moment to frame this. If implicit conversions are the devil, implicit type classes are ambrosia. They're the food of the gods.
It's true.
It's wonderful.
It's true.
They're wonderful, wonderful things.
They're
the good thing about
This is my
implicits.
primary use case for implicits
Yeah.
ever. Anyway, so Play actually has this implicit JSON API out of the box. Totally recommend that one. It's way better. There's also one from Spray, one from, I don't know, Scala Z might have one too. I think everyone and their brother has a JSON library.
JSON libraries are very common with but type classes can do an awful lot more. I wish I could tell you some of the places we've used them, but I'm not allowed to. But they are super useful. They are very, very widely used.
The idea here is I want to be able to build serialization of my objects. Like if I have an object that contains another one, I want to be able to like reuse how to serialize it to JSON in the outer one, right? I want to be able to reuse this kind of stuff. In Play, we actually have a macro where all that's compiler generated. It's cool. But this is how it actually works under the scenes, and this is how you can do similar sorts of things with your types. So we import Scala's JSON library. I just ranted about how I think it's somewhat weak, but it's there, and we don't have to import it, or we don't have to do anything to grab it in. We create a trait called JSONable that takes a type parameter T. Have we talked about type parameters? How many of you guys are unfamiliar with type parameters from Java or other languages? Anyone want us to dig in quick? Great. Okay, type parameter T.
Main thing to know is that you use square brackets instead of angle brackets with them.
Yeah.
In Scala.
Squares make cooler little ASCII faces. Okay?
They do.
So anyway, all right. Then we define our method. And the method, the first parameter to it is the type, the T. So we take in a value and return a JSON type. So what we're essentially doing is assimilating a toJSON on T. Okay? We haven't actually added it to T or anything yet, but we're creating something external to T that knows how to take a T and turn it into JSON. This is kind of similar to that value class stuff we saw before, but a little bit different. Okay? If I were a C++ nerd, which I am, I would call this a vtable. Okay, cool. I'm going to create an object called JSON that takes in a value of T, takes in an implicit JSONable of T, remember the implicit parameter, and then he's going to call...
I should point out, just in case anybody's wondering, interface is not a keyword in Scala. That's just a just a regular old variable name that we've given it.
I called it the interface. I'm sorry.
That's all right.
We can call it something else. Do you think II is better?
No, I think you should stick with interface.
All right.
You're good. It's just that, Java, that's
right.
a
That is a keyword.
So.
Yeah. I forgot about that. Okay, so yeah, we take in the interface, we call toJSON and get a value on it. So yeah, what we want is inside of here, we want to be able to say like JSON of hi and get back a JSON object, okay? And it's saying error not found, value, oh.
You haven't, so
yeah.
go up here. You don't have to do that. Just up here, hit Alt-Enter.
Probably need to make this be paste, right?
Yeah, it might be good to make it paste.
Yeah.
And then Alt-Enter. Doesn't matter where you do it in there.
Do I have to save it
No.
first?
I think it'll do the same. That's it.
Oh, nice.
There you go.
Cool.
Done.
Okay, so I would say JSON of some string and get
You
back
have
something.
misspelt Jason. It's
Josin.
Josen. Josh.
That's the egotistical version of JSON. That's where I don't like Jason, I like Joshin. Anyway, okay, so we'd like that to be able to work. I defined a person class where this does work, so I'm just going to show you. If I define a person with a first name of F and a last name of
Sorry, Josh.
clicking somewhere weird. The last name is sorry, Josh. Okay.
That is a very big pad.
And there we go. So it automatically converted into JSON because there was an implicit type class available. Where was the implicit type class? Well, let's go look. Okay. I define my case class person, and in the person object, I define an implicit object that extends the format for person. And inside of here, I implement the method. This is Scala's JSON library. So what happens is when I call this apply method for person, it's going to look for implicits in scope that give me a JSONable. Okay, it's going to look for values. Well, I didn't have any values in scope. So then what's it do? Well, there's a second stage that we haven't talked about that mostly matters for these implicit values, and that is it looks at the parts of the type. Okay? That's what the spec says. So if you ever read the Java specification, which I hope all of you have, okay, not really, but that's what the Scala specification says. It's the formal definition. And that is, the parts of the type are basically, if I'm a person class, my companion object is in the parts of the type. My package and his package object are in the parts of the type. If I'm inside of another object, that's also someplace to look, okay? And it goes down hierarchically. So essentially, the way to think about it is if to get to the person class, everything in the import chain that I have to go through is in the parts of the type, and anything in the extension of any of those pieces. So if I extend a trait, I can look in his companion object, okay? So it's kind of a big search space, but it's also a precedence-based search space. I look at the lowest level types first, I look at the person object, and then I go up the types. Now that's probably really confusing because I went in way too much detail. Read the book, it's better explained there. The simplest thing and the most practical one that we all use, man, double fingers isn't working there. I'll use this. Okay, is you can define this in the person companion object, and if it can't find one in scope, then it will use this as a default. What's cool is I can actually override how to serialize the person object. Did I just kill that?
I'm just fixing that for
Cool.
you.
So
there, I think we're back.
So you see, like I called it name and surname here. You see name and surname show up. What if I don't want to call it surname? Because, you know, I don't. I can define a new implicit.
Oh dear.
Or
you want me to do it?
Yeah. Is it because I'm... Yeah.
Sorry.
Basically, want to define a new implicit format of person in scope.
Implicit.
Okay, so this is in the local scope.
What did you call it before? JSON format?
You can call it whatever. It actually doesn't
let's
matter.
call it Fred. Implicit object Fred extends JSONable
Yeah.
of person.
Of person, and this should just write out a JSON object where name is 5.
Okay.
Yep.
So
the name is always
def2
5.
JSON value of person. We don't care what that is. We're just going to return JSON type. equals, and then JSON. Is there a JSON? What is it in the?
You
standard
have to use JSON object.
You do? Oh,
Yeah.
okay.
There's only two. There's JSON object and JSON array.
So we have to make a map of name to 5.
Just 5, yeah. The number.
5.
Yeah. There we go.
Okay.
That every person is 5.
I have a sneaky
so now-
suspicion it's going to refuse to do this because it's got
No.
ambiguous.
Nope.
No?
Shouldn't,
Okay.
'cause it's
So
not
now
imported.
we say, what was the call?
It's just JSON, but without all caps. So capital J, S-O-N.
I think it's in the buffer, isn't it?
yeah,
that one.
there we go.
There we
See,
go.
name is 5. We overrode how to serialize that particular thing in that particular instance because we're playing with the resolution of implicits.
We can
So there's-
also do one for strings. So we can say implicit str JSON extends, what was it, JSON
Yeah. The funny thing is the Scala API isn't going to be your friend here. You have to throw the string into a JSON object.
Oh, that's fine. That's all right.
Okay.
I was going to do that anyway. I was just
Go
going to
for
call it str.
Yeah,
So
that's cool.
that'll work.
Implicit object.
Implicit object.
I'll take your question while we
Yeah,
type.
sorry. Give me a second.
Oh, yeah. We'll show you in a sec. It'll show you all these.
JSON,
It'll show you all the implicit.
string.
It won't show you the implicit in the companion object because that's not actually in scope, right? Because the implicit lookup is split into 2 parts. The first part is we look for implicits in scope, and the second part is we look in these parts of the type. So it's an interesting way to provide default values.
All right. So my very dumb definition now. Now that I do that, I can now go back to the one that failed before, JSON of hello, and it actually says str is hello.
Yeah. So what's neat here is now we have the ability to not only define serialization, but let's say somebody has, they know that the integers that they're serializing are, can be optimized to, I don't know, something else, or, they have some sort of optimal format they want to use for a particular structure because they know what they're serializing. They can actually override it in the serialization, deserialization scope and not affect the rest of your users. You're providing a base level of serialization and you can customize. So it's kind of neat.
But wait, there's more.
There is more.
So 2 things that you get out of this that are huge. I mean, the reason I use type classes so much is they virtually eliminated the need for most of the cases I had for reflection before. They are the anti-reflection. Okay, JSON used to be, you wrote some kind of reflection library that went through your objects and figured out what the properties were and then, used reflection and wrote them out and all that stuff. And that has 2 problems. One of them is it can fail at runtime. You don't get any warning that it's not going to work until you try and run it because there's no compile time thing. If you don't have a serializer defined here, it won't compile. Okay, it's going to tell you right up front, I don't know how to put one of these objects out as JSON. So you get a compile time error. And the second is it's faster. The compiler does the work. It's slower from that point of view, but at runtime, everything is statically linked up and it's really fast.
Do you remember where implicit not found is?
At implicit not Scala annotation. Scala.annotation.implicit.found.
I'm going to cheat.
Okay. Oh dear. It's killing you, isn't it? You just get used to it after a while.
Here we go. JSON serializer for T.
Yeah,
I think that works.
that's it.
Yep.
And then save and Alt,
Alt F10.
Alt,
Alt
Enter.
Enter.
That's it.
All right. So now, if we were to say, JSON of 5 again, it's going to give us a much better error message. In fact, we could make that error message really long, multi-line, so that you actually get enough information, what you need to provide to people using your library. Hey, here's exactly what you need to extend and all that kind of stuff. So I want to show one more thing before we're done, which is, so I have a way of serializing a person, right? And I want to be able to serialize sequence of people, and the code is right there, so let's hide it. Can I hide it? Hide code, hide. Okay, so I want to be able to serialize a sequence of person where we have the person. He's at the dentist right now. And
Bubba.
Bibba. Okay?
That's it.
So we want to be able to serialize that, and that works. But why does that work? How do we have a serializer for a sequence of people? Well, the answer is you can actually chain implicits.
Yeah.
You can chain implicit values. What we do is we define a method, sequence JSON, that takes in another implicit for the T. So this one knows how to serialize a sequence of T and looks up how to serialize the T. The Scala compiler is actually smart enough when it goes and says, hey, I need a JSONable for a sequence of person to say, oh, look, here's something that knows how to do a sequence if I can look up something for person. And then it does an additional lookup for person.
Yeah.
So we are constructing these complex serializers from components.
This is the real value of this, because when you're using something like this JSON example is a good example. It's one that we actually use. When you write one of these libraries, typically you write a whole bunch of default serializers for all the common stuff. So you get strings and ints and longs and lists, sequences, maps, vectors, all of those are provided. Now, when you come and write your own custom thing, when you write that custom class, you provide just the serialization for that class, and suddenly it works in lists and maps and options and all of the other places, because they're defined like this. And the Scala compiler stringing them all together, so you get tremendous value from this for very little effort.
And since you're keeping things in this second level priority chain, if you decide you need a more optimal sequence format, you can override it directly in your code, and then you get it. So it's also something that you can override as needed. In general, that doesn't happen that often. It's very rare that you need to. I have one actual use case, which is if you're using Google protocol buffers, you want to be able to override if you have protocol extensions. I don't know if those exist outside of Google, though, so I might have just said too much. I don't know. Are protocol extensions part of protocol buffers outside of Google? Does anyone know?
I certainly don't. Offhand.
Okay, not that it matters. But if you were using protocol extensions, you have to use that with the serialization mechanism. Yes?
I've got a question about this JSON label, seek of T. Do you need to specify the class name rather than, new and curly brackets?
So,
At 10 and line 10, do you need to specify the
Oh.
class name?
Yes, here you do a new JSONable because it's got a type parameter. So
But the type parameter is bound
I'm creating a new anonymous class there. And sequence of T is that's the full type that it's used.
Yeah.
So it's a JSONable of sequence of something. So the T comes in from above, but yes, you have to specify sequence of T there. Otherwise, you're not giving JSONable a type to extend. It's kind of like if you look down here, when I extend JSONable, I'm giving it person. It's for the same reason. The difference is instead of creating an object, I'm creating a new anonymous class here. If I were actually making this a library where I wanted people to debug, I would actually create object sequence JSONable of sequence of T, so that you actually had a class name that had sequence in it in your debug stack trace, so you knew where it was coming from. Since this is an anonymous class, Scala gives it some like $ throwaway name. Yes.
Maybe just providing here a closure and kind of having an implicit anonymous object could be a good thing. Just like Java 8 is more or less trying to do.
So can you say that again?
Well, just instead of having this construct, new JSONable, in fact you only need to provide the method, right?
Oh, right.
So providing the
Yeah.
closure here would be a nice thing.
I know that they were looking into that. I don't know the state of it or when that would hit. But yes, that would be a good thing. I think that was a statement from Luke, which was in Java 8 now, if you have a interface that is just a single method, you can actually override it with a lambda or a function expression, which would make that particular interface really easy to implement. If it were a real JSON interface, though, there'd be reads and writes.
So can I? Oh, go on.
Okay, then it's not working.
But well, you'd probably have two interfaces, so you could, yeah. Anyway,
Saw a question.
Here you're using explicitly named there any trade-off with using the context bounds?
I was going to mention, so there's two things that we can mention here. Context bounds are just a piece of syntactic sugar that make this very nice to use. So because it's so common to do this, what you can say instead is this. And this is known as a context bounds. And what it means exactly the same.
That one
Oh,
compile.
yes.
So you have
You
to
also
look it
need to
up.
say implicitly JSONable of T.
So that's two concepts in one.
Yeah, that's a couple of things. We're desperately short of time, but
know.
that basically is. This means the same thing. It means that there is an implicit without a name, but it has to be there. The rule is that it has to be there. And then down here, this implicitly method, actually, it's just a definition. It's actually a very simple definition, but it grabs that thing that you don't have a name for out from its type and gives it to you so you can use it.
Yeah. So implicitly grabs a type out of the implicit scope and gives it to you as a value, or it fails to compile. This JSONable thing, where you do :JSONable, that actually creates an implicit parameter list with JSONable in it. Or if you already have an implicit parameter list, it will add it to your implicit parameter list as another thing it needs. The only time I would use these context bounds is when you are
Passing
using
it through.
Yeah, when you're using it and you're passing these things through.
Yeah.
Like, yeah, I know that I need serializable stuff. I'm not the one who's actually serializing, but I know I need to pass it through my API to get down somewhere.
Yeah.
That's where you put the :JSONable, because it's a much easier way of writing this particular thing. In this API, you actually, your code is a little bit more elegant if you write out directly the implicit interface, because you have to call it there. Like, you have to make use of the interface. You want it to have a name. You don't want to go relook it up off a scope. So you can give it a useful name, like II or AA. Oh, time's up.
We're out of time. I'm sorry to say there were a couple of other things. I'll put them up there just to give you a taster of what you can do. But one of the, just in closing, I will keep it short. One of the other things is you don't have to stop at one type parameter. There's actually a lot you can do when you start extending this. And in this case, I created a trait which says that type A beats type B. And it basically says opens a can and will pass on A, opens a can and will pass on B. And then what you're asking for is evidence when you try and compile this, that there's something that defines that rule. And this is a way that you can actually shift some of your logic from the runtime into the compile time, which is a really, I'll leave you to think about some of the places you could use that, but it is a pretty amazing thing to be able to do. The compiler can ahead of time check all sorts of things that you would normally that could kind of fall out as runtime errors. And also, it can be more performant as well, because you can skip those conditionals during runtime now. The compiler's already enforced them for you. So there's some real potential for neat stuff there. That was rock, paper, scissors game.
Was there
The rock, paper, scissors, I didn't actually define
constraint
them.
save? Here's another example
Oh,
of
yeah.
something actually in Scala, just to throw it out real quick. If I have a type that has some random t, and I have a method that only works if t happens to be string, I can still write it on that type. And I can use implicit evidence that t is string. If t is not string, you cannot call that method. But if t is string, you can call the method. And so that's a little sneaky way to create an API that's rich, where people can't misuse it if you need to. So.
All right, well, thank you all for coming. We do realize that we didn't schedule this as well as we might have done because it was up against the other Scala talk today. But I hope you enjoyed that. Hope you go away thinking that maybe implicits aren't the devil. And what they are really, when you summarize it, is they're the first tool. Scala gives you many of these, but they're the first tool to actually augment the compiler logic in ways that you want. You can specify more in your types using implicits than you could otherwise. And there's actually, you can go further then with macros and compiler plugins, which are, compiler plugins are just basically open up the compiler and shove code in. I mean, it's, you can pretty much do anything you want to with those. But implicits are a great way to extend your capabilities.
Yeah.
All right, we'll be around for...
You should attend Dick's training and buy my book.
Yes, do that too.
See you
Good
guys.
plug. Thank you.